Hi friends, I'm Yugen. Welcome to my YouTube channel Interesting Quantum. In this video, we are going to see how to find out the wave function if we know the potential. So let's start with the Schrödinger's wave equation IH cross dabba by dabba t of psi, which is time as well as position dependent, is equal to minus h cross square by 2m del square psi plus v psi. Here v is also time position dependent. This equation we have studied in some previous videos. So if we know the potential v, how can we find out the wave function from this equation? So we have to see the variable separable method in this video. In this method, we separate the time part and the space part of the wave function like this. Now psi is only dependent on x coordinate, so this is special case, or we can say this is simpler case because it is in one dimension. If it is r, then it is in three dimension. So we have separated space part and time part. In this case, space part is at initial condition, so we can also call it as a stationary state, and the time part phi is equal to e raised to minus I e t by h cross, or we can say minus e I t 2 pi upon h, where h is Planck constant. So if we separate this, and we can write as psi is equal to time part into the space part. So this is the basic idea of variable separable method. So V, that is the potential, should be time independent. So if and only if the potential is time independent, then only we can use this method. So this is our original equation, Schrödinger's wave equation. So if we apply variable separable method, we can reduce this equation as minus h cross square by 2m del square psi of r plus vr. Here v is only position dependent. Psi r is equal to e into psi r. Here from all the equation we have eliminated the time part, so this equation is also called as Schrödinger's time independent wave equation. For one dimension, it can be written as minus h cross square by 2m del square phi by dx square is equal to e minus v of psi. We can solve this equation and find out the psi. So what is the special about this variable separable method? So there are three different specialties. One of them is the probability of wave function is always independent of time for a stationary particle. We will see some examples in further videos, but we have calculated probabilities for some functions in previous videos, and each time the space part is only important, the time part always vanishes in the integral. So we can separate out these parts and we just multiply by time part after getting the solution of space part, and that is our total wave function. The total energy of states, which we call Hamiltonian, is also constant of time. So the total energy is not changing over the time. So this allows us to separate time part and space part. These two are physical reasons, and final wave equation is linear combination of different solution. This is mathematical. So as we have seen in previous videos that we can write the wave function, total wave function, in the form of some different wave function as their addition. So this is a linear combination. So we can write the total wave function is equal to summation of space part into time part. So e raised to whatever that is the time part, and summation cn of psi x0 is the position part or space part. So in this way we can calculate the wave function. So to calculate total wave function, we just need to calculate the stationary state psi of x0, x and 0, that is at t is equal to 0. So this means we will calculate the initial wave function and then we will just multiply it by e raised to minus rent by h cross, that is time part, for every case. But the only condition to apply this method is our potential energy function should be time independent, and then only we can apply this. So in further videos we will calculate the wave function for different potentials like infinite potential well, harmonic oscillator, the free particle, the delta function, the finite square well, and so on. So enough for this video. Thank you for watching. Like, comment, share, and don't forget to subscribe and press the bell icon so that you will get the further notifications for next videos. Thank you for watching.